This video is all about formulas for friction. All right. Friction is a force resistive to the direction of motion. The friction force is proportional to the normal force perpendicular to the surface between two objects. The proportionality constant is called the coefficient of friction. Now we have the following variables as Fr is represented as friction force, or we have Fs or Fk, Fs for static friction, and Fk is the kinetic friction. We have N as the normal force and mu k as the coefficient of friction. Now we have the formula for Fr, frictional force. This is the force at which we're going to consider the acceleration and velocity of an object. So Fr is equal to the coefficient of friction, mu k, times the normal force n. We have W as the weight, wherein weight is equal to mass times gravity. M is the mass of the block, usually the block on the analysis. Okay? And gravity is 9.8 meters per second squared, and F is the force is exerted to push or pull the block. Now, let's differentiate coefficient of friction mu k versus the coefficient of static friction. Now, consider a block at a horizontal plane. Okay? The block now is placed on a horizontal plane, and this is pulled at a constant velocity. Now, if a block is pulled at a constant velocity, we're going to use coefficients of kinetic friction. Why is it so? When we say kinetic energy, we're going to deal with mass and velocity. Now, since the block is moving at a constant velocity, we're going to use our frictional force Ff would be equal to the coefficient of kinetic friction mu k times the normal force N. The normal force N is the force that is counteracting by the surface to counteract the weight W is equal to mg. Now, for the coefficient of static friction, this is used when okay, the block is stationary or at rest. Okay? For coefficients of kinetic friction, we're going to use this when the block is moving with a velocity or speed. And for coefficient of static friction, we're going to use mu s when the block is stationary or at rest. Now, to calculate the frictional force, this is equal to mu s times the normal force. Okay? We're going to consider the FBD as the normal force counteracting the weight of the block mg, and this is being pulled towards this direction of the force F.